Hey guys, welcome to our technical drawing tutorial, and if you have any questions or comments or suggestions, you can send them to autocadalive@gmail.com. So in this tutorial we are going to be doing the simple method or task of finding the true length of a line. There are three methods that can be used to find the true length of a line, and the first that we're going to look at is the revolutionary method. The next is the triangulation method, and the other method that can be used is the auxiliary projection method. So one might ask, why is it important to find the true length of a line, or what is all of this about? Well, let's take a look at this simple example. Simple? Well, let's dive in. So imagine you throwing a javelin stick, and this javelin stick lands on the ground. This would be your ground, grass on it perhaps, maybe sand. And it lands on that ground at a particular angle. And at an angle to the horizontal, and also that to the vertical plane. So in the vertical plane position, we're looking at a wall, maybe a concrete block wall, plastered, unplastered, you decide. And in the plan view, or the horizontal plane, we're going to look at the ground on which the javelin stick lands. And then let's place two lamps. One, a wall-mounted flood lamp, obviously on the wall, and on the ground, another flood lamp. These lamps are going to shine their beam of light at two different angles on that javelin stick. The lamp on the ground shines its light on the javelin stick, and that shadow appears on the wall. Okay? And the lamp that has been wall mounted does the same, shine its light, or it allows a shadow to fall, shadow of the javelin stick to fall on the plan view, or the ground, the horizontal plane. These two shadows could be represented with a line. The angle of that line varies based on how the shadow appears. So we have two lines in this example, and we could label this line B, or this point, this top end of the line B, and the bottom end A. And in the plan view, A prime and B prime. All right? Now we are directly taking these two lines, leaving out the javelin stick for a while, because we know if we measure the actual javelin stick, we'll get the true length of the line. The true length of the line is found by measuring the actual javelin stick. All right? But let's say the javelin stick has been removed and we have left our line AB and in the front elevation, and our line A prime, B prime in the plan view. Now we're moving to the revolution method. I have in this first part of the drawing, in the top part of the drawing, a line AB, which could mirror our line from the light, or the lamp, the shadow from the lamp mounted on the ground. And that shadow appeared on the wall, which represents our horizontal plane. And in this position, right here, A prime, B prime, our line from the lamp mounted on the wall, which gives us our plan view. All right? Now, our wall is not entirely straight, so that tells us also that our line is not entirely straight. Okay, though it may appear in that way in the drawing, it's not entirely straight. So, in our revolution method, we are asked to do one of two things. We could use the front elevation as our position to draw the required arc, or we could do it from the plan view. All right, so we're going to do it from the front view or the front elevation first. And what we're basically doing is perhaps placing our compass point at one point and then drawing an arc that should give us the actual location for our length of line, or the actual length of the javel stick on the plan view. So let's take a look at how that works. Compass point will be placed at point A. An arc is going to be inscribed whose radius is equal to the length of the line or the shadow AB. Bear with me here, I just need to make sure this is very accurate. Okay, so this is my arc. And be very careful not to draw the arc to extend to touch our XY line, which represents our horizontal plane. Okay? So we basically want to see what the javelin stick would look like, or the length of that javelin stick against the horizontal plane. Remember, based on the position of the wall mounted lamp, the light shining on the javelin stick casts a shadow at an angle on the horizontal plane, or on this floor plan, all right? On the floor plan or the plan view. Let's not get confused. Again, the light shining on the javelin stick gives us a line at an angle on the horizontal plane, thus our plan view. So we need to find out exactly how long that line is going to be. And so we proceed, I'm going to leave this right here, we're going to proceed with drawing a horizontal line and that horizontal line has to be drawn parallel to our horizontal plane, our line XY. Okay, so we use XY as our reference line. I'm going to slide our set square to point A, or the bottom of that shadow, and extend it so it intersects with the arc drawn with point A as its center and the length of our shadow as its radius. And from there, let's just, for argument's sake, label this point 1. So we are going to now extend from point 1, we're going to extend. I'm going to use the horizontal plane as my reference line. Because I don't have a t-square. And we're going to extend, well, take this a little further. A little further because I want it longer. Alright, around here should be good. So we extend, or project rather, a vertical line from, notice, it's going to be extended from our line A1. Okay, at point 1 on our line A1, vertical line extended. Now you might say, boy, this line is really going to be longer, obviously, than what is seen in the plan view. Again, remember, the wall lamp is mounted at an angle. The javelin stick is thrown at an angle, but more so the javelin stick thrown at an angle, the light shining on it, which is not directly on top of the javelin stick. Right? It casts that shadow which appears to be shorter than the actual length of the javelin stick. Now in this we know that the javelin stick is longer, but let's see how much longer it actually is. And so we are now going to use our line XY as our reference line, right? And we are going to slide our set square down to point B prime. Okay? And we're going to draw a horizontal line from point B prime to meet with our line from point 1. Let's label that line's point of intersection 2. Our next step, you're going to draw now a line from point A prime to point 2. And by doing so, you would have now drawn the true length, or found the true length of your javelin stick. And so this is how it is found using the revolution method. Very simple, very easy. Line AB, your radius, inscribe your arc. Extend your line from point 1 and extend also from point B prime. Point 2 is the next end of your line. Point E prime is the origin, and so we have the true length of the line found. So the true length of the line is A prime 2. Your line A prime 2 is the true length of your line. The same method now done using the plan view. And that should be done a lot quicker with less explanation, right? Because we should have understood. But if we don't, that's okay. We're going to do it anyway. And that is done by using, this time, A prime, B prime as our radius. From there, we're going to inscribe an arc. And parallel to our XY line, our horizontal plane, to be very careful here, parallel to our horizontal plane, we need to identify point 1, and we move to point A prime, at which point we're going to draw a horizontal construction line, and it intersects with our arc drawn from a B prime with radius A prime B prime, and we label that point 1. Having found point 1, we draw now our vertical line, and this vertical line has to meet, or has to be drawn from point 1 rice and fries. Of course, all of this would be done a lot easier if you have a T-square to get this vertical line drawn properly. But in this case, I don't have a T-square, so I'm going to improvise and use the set squares. And of course, when you improvise, sometimes a degree of time is wasted. And this right here is our vertical construction line. Your next step would be to draw a horizontal line that would start at point B and intersect with your vertical line that went upward from point 1 from your plan view, similarly as done in the front elevation. Taking my time to line it up, which is very important. Then you slide the seed square up to point B. Construction line drawn, point B, line extended from point B and from point 1 intersects at point 2. You proceed now with one line that should allow you to join point A to point 2. And as a result, you would have now found the true length of your line, and that is represented with the line segment A2. Okay? And to conclude, by using the revolutionary method, we would have lined up our shadow with the angle at which the javelin stick landed on the ground to give you the true length, one line representing the true length of that javelin stick. In our next tutorial, we're going to look at the triangulation method and the auxiliary projection method. This intro example will not be included, so please go through the video. If you don't understand and would prefer another intro to the topic, feel free to send me a message. Thank you.